flipped over to there is coming off of the screen that's not working. So we're recommending that you guys in the remote classroom come on over into this room. We probably have about 100 seats empty in here, so we have plenty of space. Okay, so first up, we got some bad feedback from our speaker last week about you. This isn't the kind of thing that an instructor or a teacher wants to hear. You got to be polite. You got to, well, frankly, you got to be quiet, and if you don't like it, too bad. All right, this is just common courtesy, and I don't want to be hearing from other faculty members that people in here were being rude, that they were not listening, standing up and leaving midway through. Suffer through it. Okay, if you're not interested in it, if you're not an electrical engineer or whatever, we're going to be having guest speakers from the other departments. If you can't manage to be polite, well, God help you, but if you can't manage to be polite, please don't come to class on that day, all right? This is not the kind of feedback that I want to be getting from other faculty members about how well we run our classrooms. And frankly, I don't see you guys being all that bad when I'm lecturing. But Dr. Volstead told me about what was happening in here, and she was not happy either. So please, I think this is a pretty reasonable thing to expect. Okay, so to business. Reminders. We've got checkpoint 4 coming up next week. We also have Thanksgiving. Yay. So we're expecting that a lot of teams are going to be working on Monday to get their hovercraft flying down to the other end of the board and stopping. So I recommend that you actually don't wait until Monday to work on this. So to be clear, for checkpoint 4, you have to have your hovercraft start, use its propulsion system, go to the other end, sense that it's in the black turnaround zone, but you don't have to turn around for this checkpoint. You just have to stop before you hit the back wall. So you need to have a working program on your NXT. And our lab, the EDL, is not open over the weekend. So if you don't have LabVIEW on your own personal computer at home, or your laptop or whatever, you're going to have to make sure that you get access to that software to write your program either between now and this Friday or starting up on next Monday. So just want to point out these little issues that you have to work out. We're expecting it to be very busy on that Monday. We're going to try to have extra people in there. But frankly, the problem, the bottleneck that we have is that we have all 100 teams debugging on Monday, and there are going to be lines queuing up at the 4 competition boards, because now everybody has to test it out on that board. So just try to envision this. If your team can at all work on this stuff this week, before the rush next week, we recommend that you try to do that, because it's going to get busy on those competition boards, and we're going to have to police it. You can't have people hogging the board, so take a run and then get in the back of the line. Let someone else get and take a run. So the checkpoint will be on Tuesday and Wednesday of next week. So we're not going to have a lecture on Wednesday. And it'll be run similarly to how we did the last checkpoint. The actual activity will take about 5 minutes per team, so it goes fairly quickly. And with the last checkpoint, we didn't have too many lines forming. It was principally just a matter of space, because we ran out of tables and chairs and things like that. So that kind of a thing might happen again next week. So CATME 5 survey is due, I guess that's next Monday, if my memory's correct. And when you come back from Thanksgiving, we're going to have a series of other high-value assignments that are going to be due, the first of which is going to be an exam. We'll get to that in a second. So the details on the checkpoint 4. So anytime between 10 a.m. and 5 p.m., I keep looking at that blue screen. Anytime between 10 a.m. and 5 p.m., you should have a fully functioning and autonomously operating, one moment. Okay, now back to our regularly scheduled program. So when we say autonomous, technically for this assignment, for this checkpoint, all you really have to be able to sense is when you've reached the point at which you have to stop. So if your propulsion technique is based on a weight shift, you are allowed to set that up with that forward-moving bias at the start line. And all you'd really have to write your program to do is to stop it. You wouldn't have to write the program to start it or anything like that. If your propulsion system is based on rotating a fan and to reverse your direction or something like that, you probably don't even have to have that part functioning yet, because you don't have to come back to the start line. You only have to have this thing going in one direction and stopping. All right, so that's the basic assignment. You are encouraged to not hit the back wall, but there's actually no penalty for hitting the back wall. All right, I recommend that you try to get it to stop before that, because in the other assignments that come after that, there will be penalties. So work on it, but don't spend 2 days getting it to stop precisely. It doesn't matter. Your score is based on how far down the course you get. Okay, so read the rules, read the grading, and great. Okay, so. Okay, so that made me feel foolish. All right, so the whole assignment's worth 25 points. Everything that you're going to be flying with should be on the hovercraft, and you're going to have a 5-minute window to complete it. If you touch the ground or something like that, then you have to start over again. So if you stop hovering for any reason, you'll have to start over again, and the clock is ticking. That 5-minute window will be ticking. So we're going to give bonus points if you get it on the first attempt. So obviously that should be everybody's goal. So you can check out the detailed grading criteria online. So after we come back from Thanksgiving, there's going to be an exam. It's essentially the final exam for your skills lab. After you're done with the LabVIEW activities this week in Skills Lab, there are no more new real Skills Lab activities. It's all going to be things like the exam and your final oral presentation and stuff like that. So we're running out of weeks, basically, towards the end of the semester. All of that week, whenever your Skills Lab is being held, you'll do the exam right in the Skills Lab. And it's worth 100 points, all right? It's worth 4 times what your next checkpoint is worth. So it is going to be on essentially everything that you've done in Skills Lab, including the reading assignments and all of the basic topics that you have in the Skills Lab. Okay, so it'll cover things like MATLAB, it'll cover things like LabVIEW, it'll cover all of your reading assignments, fuel cells, batteries, basic circuits, all of these types of topics. Okay, question? It'll be conducted online, but it will be in person. So you're not doing it in your dorm room, you're doing it in the Skills Lab itself. Okay. Another question. Is there a study guide for it? Well, I could give a wise-ass answer and say, yeah, the whole semester. But that's basically it, okay? We don't have an explicit, I'd say read the book, go back and look at all your notes for the Skills Labs. That's what's fair game on it, okay? All right, after that, the week after that is going to be your team's final oral presentation. It's going to look an awful lot like what you did for your first presentation. This is your opportunity to brush up on all the things that you lost points on. Try it again. Obviously, you'll know a lot more about your design. It'll be a lot more finalized. That was a preliminary design presentation that went along with that preliminary design report. You're going to be updating that report and writing a final design report and giving a final design presentation between now and the end of the semester. Fortunately, hopefully you don't have to completely rewrite everything in your report, because you did a lot of that the first time through. You just have to update it, update your budget. If you've changed your propulsion scheme, they have to tell us what the new plan is and all that kind of stuff. So all of these other things, you can take a look at these aspects. Same advice that we gave you last time is read the grading criteria. Many people, especially for the report, the written report, we're not talking about that just yet. Many people didn't really read the report carefully. Many teams did not proofread their writing, and they lost like 20 points on stupid grammar stuff, okay? That suggests that either the wrong person proofread it and the wrong person wrote it in the first place, or they didn't do it at all, which is more likely. If you aren't clear about that, have all 4, 5, or 6 people on your team proofread it, because it's worth that much, okay? So just my advice. All right, so today we're going to cover, I think it's the second to last of our actual content, and between now and the end of the semester. The other lectures are going to be visitors from the various departments talking about different disciplines of engineering. But for today, we'll talk about efficiency, effectiveness, and the economic sides of things, And the next one, I think it's in 2 weeks, we'll give a little bit of a lecture on ethics in engineering. These altogether sort of constitute what we call the soft skills of an engineer. By soft, we don't mean by trivial. In fact, these are some of the most important skills of an engineer. These are the things that will get you hired. They're very hard to measure in an interview, but you will probably get asked off-the-wall questions about, this is what we've got, this is the situation, what would you do? And there's no right answer. Well, maybe there's a right answer, but they're going to test your values, your judgment, your ethics, all of these kinds of things in these interviews, because those are the things that they're going to care about when you're working out in industry. Okay? You got to have good engineering skills. You have to know how to do calculations. You have to know how to write reports, all of those other things. But the soft skills that it's really hard to create one single course around are what are going to matter a lot. You're going to get some of that here this semester. When you take what we call Engineering 301 later on, it's Engineering Communications. We call it Engineering Communications, but that course is way more than just communications. You'll cover ethics and things like that. And you'll also cover ethics when you get to your senior design projects. So you're going to be getting this stuff at a lot of points along the way. And what ethics means to an engineer is not necessarily the same as what ethics means to a business major. Okay? We're much more concerned about how what comes out of our head does in the real world. And their ethics comes into these types of questions at all levels, as does economics and efficiency and these types of things. So let's get to today's. So in a perfect world, an engineer or a computer scientist develops a product that would be the perfect product. And the process would work every time, right? The product never causes any harm to its users. Their business isn't affected in a harmful way. The environment isn't harmed in any way. The product never breaks, never fails to do what the customers are expecting it to do. There are no unintended collateral damage to people other than the customers who bought it in the first place, right? It should be developed, designed, and manufactured in a short period of time to allow you or your company to respond to rapid changes in the marketplace. This is a fact of life these days. It serves all of the needs of all of the customers, and it can be cheap, right? This is the perfect world. The analogy that we give in engineering, we go back to our Venn diagrams. There are 6 things here. We can break them down into really 3 things. A lot of them all can be grouped together, and we call that the quality or the goodness of your design. Your product or your design can be good, it can be fast, and it can be cheap. Pick 2. That's the reality that we apply to the process. It's not so hard to make a product that's good or a product that's fast or a product that's cheap. Getting them to be both good and cheap is kind of difficult. The amount of overlap between those is somewhat small. In order to get overlaps between all 3, it's generally impossible. We have a donut hole right in the middle there where it's generally not possible. And what makes this impossible is that there's usually something that's holding your design back, something that's limiting things. And to make matters more complicated, if you think that you made it good, fast, and cheap enough, somebody's going to come to you and say, I want it cheaper. And it might not be your customer, it might be your boss, because the shareholders want more return on their investment. They want to take more money out of the company. Or maybe your company wants to squirrel away more money to invest in a future product down the line. They're going to pressure you to make something that you thought was perfectly cheap and perfectly good enough, all those other things, but they want it to be still cheaper. And you're going to have to use your judgment as an engineer to figure out how to make these decisions. This is the fact of life. In spite of all these things, all of these courses that you're taking, math and science and English and communications, all those big long list of engineering classes you're going to be taking, the things that companies tend to really care about when it comes down to it are your ability to know the product line, make judgment calls about not only the product line, but what's necessary to create it in the first place, how to keep it up to date, how to keep it safe, how to make improvements in the future, how to make adaptations to fit changing marketplaces. These are the practical things that an engineer is expected to do. Many of these have connections to business goals, but it is the technical side of things that the engineer is going to be expected to respond to. Your job isn't going to be to figure out how to advertise it, for example, but you have to know how to find features that might make it better, right? Microsoft and Apple, they're really good at this, right? They send you an updated version of their operating system like clockwork and ask you for another $50 or another $300 if it's Windows. I mean, you know how this works. They update it with incremental improvements. These are things that the business people say they want to do. Otherwise, people would just stick with the operating system they had on day one when they bought their computer, and Microsoft would go out of business, right? They wouldn't have continuing revenue streams, not to mention the fact that the product would get stale. Okay, so they figure out ways, the business people figure out ways to say, all right, engineers, we want these new features that you told us you could probably do. We might actually want you to hold off on those for a little while. We're going to include that in version 2.1 rather than version 2.0 because it goes better with these other upgrades that we're going to release at the same time. So these types of strategies and approaches are commonly done, and sometimes they're driven by business, sometimes they're driven by limitations of the technology, and sometimes they're just driven simply by costs. But the engineer is going to be closely tied to many of these, maybe not all of them, but many of these various issues. These are going to be critical decisions that many times you as the engineer are going to be asked for input on, and in some cases, you're going to be the one who calls the shots. And this is where careers get made or broken if the wrong decisions are getting made. So, first clicker question. A little bit related to this. Which of the following aspects of your design process has caused your team the most headaches? Is it a time thing? Time to do the design, time to do the building? Communication, understanding all the rules and regulations, and we know there's a lot of them. That's on purpose, frankly. Costs, or is it something else that we're not seeing on this list? This is feedback for us, too. All right, let's look at our results here. I'm curious what these are going to be. So the largest was the time to build the hovercraft. We tried to communicate the necessity to get started as fast as possible, but we understand that sometimes it takes time for your parts to arrive, for example. We didn't see teams working much in the lab until maybe a week and a half before the checkpoint that you had to be hovering. Fortunately, you have it built. And from this point forward, it's incremental changes. So I'm not going to say it's easier, but I think that it'll be a little bit different. The design tested you a little bit. Lots of problems in the other directions as well. Costs weren't really an issue. That's good for us. We were a little concerned whether the costs were getting out of control. But good. We asked this question because many of these things are considered resources. And one of the key things that an engineer is concerned with is the optimal use of resources. Efficiency relates to resources. And when we talk about resources on an engineering process or project, resources doesn't just mean money or electricity or something like that. Resources is anything that you need to produce your product. And in this class, resources can relate to the kinds of things I just asked about a moment ago. Time is a resource. Money is a resource. Access is a resource. Information, knowledge, understanding is a resource. Infrastructure, buildings, space, facilities, tools, things like that. These are all very important things to get projects done. I think this is a little bit common sense, but an engineer looks at these just as stuff to get the job done, okay? And in many situations, you're not going to have all of these things in hand. So another resource might be considered access to external resources. Do you know people where maybe you can borrow their huzamawatsi to get the job done? Or maybe your company has a partner company where you really have your own separate product lines, but they've done you a favor in the past, and maybe they'll do you a favor again, and you'll owe them one. Or maybe they owe you one already. Okay? So information, access, money, time, and people, and sometimes people just translates directly to expertise, are all very, very important resources. And your job as an engineer is to get the most that you can out of all of your resources. Engineering problems are generally not easy. Your boss might hand you a project that seems very isolated and compartmentalized and not really connected with the rest of the world. But 9 times out of 10, your boss is thinking, no, I'm not giving them the hard stuff. Okay? This is a new employee. I don't want to drown them with how this new product fits into our 20-year plan for our future product lines, for example. Another example would be maybe the product itself is just inherently really complicated. The project has to be, you have to figure out a way to apply the resources to the project that makes sense. You guys have been doing this all semester, right? We asked you guys for a Gantt chart in which you figured out the timeline. Implicit in that Gantt chart were all of the resources that you had to work out, right? You had to work out a timeline of all the various stages of your project. But built into that were your resources. Most importantly was your time, okay? We will spend 4 weeks doing this. All 5 of us will work on that one thing. Was that the best way to do it? Maybe, maybe not. Maybe you needed to get that one thing done before you could divide up the next stage into 3 teams, 3 sub-teams. Okay? This was a process of resource allocation that you've been doing all along. This kind of a thing plays a significant role to project engineers. There's a category of engineers called project engineers that most universities don't have a degree in project engineering. They'll have courses in project engineering where people who are good managers, good people skills, they're organized, and they have enough technical skills to be able to run projects. They get a specialization in project engineering. And you can get graduate degrees focusing on project engineering. It's where engineering overlaps a little bit with business, some aspects of business majors. Okay? These types of things are valued skills. In fact, a lot of employers are coming to us nowadays and saying that we need more project engineering courses because this is a skill that we want our future engineers to have a little bit better mastery of. So these project engineers will look at a complicated process and figure out what the best way to approach it is. And there's a lot of approaches. The most brute force is you do this first, you do that second, you do that third, and it becomes a very linear process for getting things done. And it doesn't really match very well with our typical approaches to getting things done faster or better. Right? When someone asks you to do something better or faster, it usually means something like get more people to help or get a better piece of equipment that can get it done sooner. All right? And these different approaches usually involve different points of view on how it's being done. They're not a linear one thing after another approach. Okay? To get something done in a linear manner faster, it means that you need smarter employees with better skills. And that's a little bit different than having more people who all have adequate skills. All right? So, and sometimes something can't be done any faster. There's just no, it doesn't matter how smart you are, something just can't be done faster. So, we try to figure out divide and conquer kinds of strategies. We talked about this in our problem-solving lecture a few weeks back. It applies for resource assignments as well. Break the problem down into small pieces where you can work on things in parallel. Many teams are starting to do this, we've been seeing. Some people will focus on getting the batteries ordered. Some people will figure out the programming side of things. And while they are getting the hovercraft hovering, this person over here is focusing on learning how to write the LabVIEW program or how to make improvements on it or whatever. You get the idea. Breaking the problem down into smaller pieces makes sense, and the knee-jerk reaction, and it makes sense most of the time, but sometimes not, we'll get to that in a little while, is to assign the people who are best at those things to do those things. The people who write the best probably should be the ones who write your report or who write that product literature that you hand to your customer when you're trying to convince them to buy your product. You don't want to have your worst person writing the stuff that you're handing to your customer, right? That's kind of common sense. Okay? So assigning the most capable staff to work on the tasks for which they are most qualified. And you have to make judgment calls on these types of things. You want to try to pick on the tasks and schedule the tasks to be done at the most appropriate time in your Gantt chart timeline. All right? So it might depend on resource availability. In this class, you can't write your program until you have a resource. Right? What was that resource that you needed to have in order to write your LabVIEW program in this course? You needed knowledge. Right? You needed a skill. And that's what companies look at it as. Most of you didn't know how to do LabVIEW on day one. So you couldn't say on day one, I'll do the hovercraft and you do the program. Because the person who does the program is going to be twiddling their thumbs until mid-November. Okay? That's common sense. So you have to match your resources to your timeline and what resources are available and when they are available. And in this situation, the information is a resource. The skill in the staff, in your personnel, was one of the resources that was necessary for this. So, when you have an overwhelming problem, sometimes you can't take an approach. In fact, oftentimes, really, if you have a product-oriented company, you probably don't have a choice but to look at the problems and look at doing your job in small pieces. But that's sometimes not enough. Sometimes you have to actually do sampling. By sampling, we mean that not everything is checked. That's really what it means, where you are selecting individual things because maybe it's just impossible to check everything. The scale of the problem is too big. Like, for example, if your job is to test all of the shipping containers that come into the United States to see if there is a nuclear weapon on board, there's a terrorist coming to get us, right? This becomes a problem of scale. There's so many of these things coming across the borders so frequently that it's hard to do this. Technology is limited. Maybe with better technology we could test them all, but right now we randomly sample ones to open up and test. It's a customs thing, right? Where you're looking for illegal things, and in these cases you're applying radiation sensors to them all and detecting them all, as many as possible. So inspections are done on a random basis or maybe a targeted basis depending on the circumstances. But other reasons that you might want to use sampling is because sometimes the product just isn't suited for every single product that comes off of your assembly line to be checked before it is delivered. Like a car, for example. They turn them on. Every one, they turn on and confirm that it drives before they deliver it to a customer. You can't do that with a lot of other products. Sometimes a product is really expensive and it's a single-use product, like an airbag in a car. They don't test it before they pack it back up and give it to you, right? Because it's a single-use kind of thing. Flip-tops and cans. This is a classical example. When I was your age, these things didn't exist yet. They had these pull tabs, and there was like a 50-50 chance that you were going to rip the tab off, and then you're left with a can with the lid still on and nothing to pull it off, right? So then you have to get all engineer on it and get a screwdriver out of your kitchen or something like that and poke holes in your can to get access to your beer. Nowadays, they've tried to improve this. They have these flip-top cans that I'm sure you guys are all more than familiar with. And how do you test these, right? You can't like put it back together and then give it to the customer, okay? This is another example of something where you have to actually develop a sampling scheme by which you can do this. Some products do not get tested because they are inherently impossible to test, like a nuclear bomb shelter or something like that, you know? These are obvious ones, right? But there are a lot of other products that they don't test because it's too expensive, too dangerous, or because it's only intended to be used in a situation that is inherently unsafe or is rare. Okay, so you can kind of get the idea that sampling is a fact of life. Testing of welds in a pipeline that extends for 2,000 miles across the Arctic of Canada. You're not going to have somebody walk along the inside or even the outside of that pipeline and testing every square inch of that pipeline. It's just not feasible. So they'll do some kind of a testing regimen where every 100 yards they do a random test, or every 10th weld seam they'll bring their X-ray equipment and check to see that the weld was done correctly. Or maybe every 1,000th hard drive coming off the assembly line is plugged in and tested. You just have too many to test all of them thoroughly. They'll probably do some basic tests to confirm the LED goes on when they power it. But to actually confirm that you can write 200 gigabytes to that drive, like it says on the top of the drive, this is a 200 gigabyte drive, to confirm that there are no bad sectors, bad cylinders, blah, 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 it takes time. And these tests might actually slow down everything. So how you go about doing these types of things is, on the one level, we call it common sense. But on another level, you have to know what tools are available to you. You have to know a lot about your design process, what your schedule is, what your resources are to get all of these efficiency decisions made. These require skills, okay? So it's not just common sense, okay? So you'll have to be expected to do these things. Bear in mind that these questions of efficiency are oftentimes not simple, okay? It's really easy to find the low-hanging fruit. You know, is it good, is it bad? What's the best way to get done before the end of the semester? Your team might have had a certain person do the writing because they're the best person at writing. But what about the person who wasn't so good? Why are they here in the first place? To learn, to get better at this stuff, okay? So from a management point of view, it might be good to get other people on your team experience in these other skills that maybe they're not the best at, okay? There are many levels of goals in your company, and they're not always customer related, not directly. Maybe long-term they're customer related, but there are short-term goals, there are long-term goals, there are company-focused goals, there are customer-focused goals. Many of these things are associated with costs today, and many are intended to affect costs down the line. Okay, so bear in mind that they're not all customer related. Okay. Example. Let's say that, going back to our example of inspecting weld seams, maybe you have a team, maybe you have 50 teams, I don't know, whose job are to inspect welds. This is a very common thing, especially in situations where you don't want a natural gas pipeline to blow up because it had a leak. Right? So you have to inspect that and confirm that there are no leaks. You have a team doing this, and you might have a team supervisor who is very, very good at their job. Okay? And they can do it faster than anybody. the inclination of many companies is to say that that's the person I want to be the supervisor. But think about that. That supervisor isn't going to be doing as much testing as they used to be. They were the fastest tester before, the best person doing the job. And now you've taken them out of that job and says, all right, now you manage these 15 people under you who will do it instead. You've taken your ace pitcher and you've put them into the coach's box rather than actually doing the pitching. Okay? Doesn't make sense on the surface. However, if the company approaches this in the best possible way and the expectations of what the supervisor is supposed to do are made clear, and hopefully they have good skills in teaching that to others, then they can share that knowledge of how to be the best welder or how to be the best weld seam inspector to everybody else. Okay? So the short term, it hurt you because you took away your best person for that job. In the long term, provided they're good enough to share that knowledge, and good not at inspecting, but good at teaching, which is a different skill, then there might be a long-term benefit. Okay? A lot of companies approach this wrong because they look at promotion. I say wrong. All right, let's just cross that out because sometimes it's not wrong. They approach it differently because there is an expectation that you will be rewarded for being good at your job, right? You want that promotion, and if you don't get it, you're going to go somewhere else because the pay's better for supervisors, frankly. Okay? Companies generally have to find ways to reward people without hurting the long-term payoffs for the company, and the long-term health of the company. Maybe you give them a promotion, but it's to a position where they can share that knowledge. Maybe you don't promote them, but you give them a $30,000 bonus at the end of the year because your company had a huge windfall profit, right? You share the wealth. There's lots of ways to get rewarded, and promotion is oftentimes not the solution, but many businesses do this. And I say that because you've probably all heard that somebody was so bad at their job that they got promoted, right? They got kicked upstairs because no one could stand working with them. This is a reality in the business world, okay? Think about it. There are probably good reasons why that happened at the company, okay? Probably because the persons were perhaps not so bad that they would get fired, but the upper management is taking a chance that maybe they're not the best weld seam inspector, but I think they might be better at teaching people how to become adequate weld seam inspectors, so we'll promote them into that job. Okay? These are touchy-feely business decisions that affect employees, but you're probably going to experience them. In the early parts of your career, you'll be on the receiving end of these things, and in the more senior portions of your career, you're going to be one making these decisions. And be aware, efficiency and effectiveness and all of these things impact everybody at many, many levels. Okay. Let's see. I sort of already talked about all this stuff. So, summarizing, these issues of efficiency and effectiveness are certainly going to influence your company, but by and large, the decisions that get made at your company require employees who know how to make decisions that are appropriate for your company and in your job that are relevant to things. And in order to do this, it's not going to matter how good your differential equation skills are, frankly. It's going to matter how good your, I say common sense, but common sense can be taught, and how your common sense meshes with your common engineering sense about what is feasible, what you can do with your resources, and what's the best way to share those resources. So, clicker question. Of these, which is the following that you would propose as the most important contributor to your career? This question is not so obvious. I hadn't prefaced it with a lot of what we were just talking about, but even so, a lot of people disagree. Wow, more than I thought. What I would offer is it's the last one. Not to say that the first four are not important, but I'll say that unless you have the last one, the first four, you won't even get a chance to display how good your math is, how good your design skills are. Because if you're not in touch, if you're not in tune with your own products at the company, how they fit into the marketplace, how they meet the needs of your customers, what they cost your company to produce, all of these types of things, then Everything else, all of your technical skills, all of your engineering skills, all your business skills are going to be isolated to the point where they're not really connecting with your product. All right? Companies, when they hire employees, they're not really caring about how good their technology is, frankly. What they care about is how well they're meeting their customers' needs. And to do that, you've got to know what your products are, how they're produced, and how to do them the best way you possibly can. So, falls under the guise of common sense, but common sense with an engineering slant applied to it. Okay. Question. Consider the following conundrum. Your company has received a contract, meaning you've signed on the dotted line and you've promised to deliver something, and your customer has promised to give you something in return, most likely money. Okay? You are making a new replacement seatbelt design that is intended to go into a specific car model. Maybe it's a quick release thingy, whatever. The details aren't terribly important. But you've contracted to develop and produce a new product. The seatbelts, where you're going to be using a new kind of buckle, but the contract requires that you must have not only design, but production and delivery of the first set of seatbelts within 180 days. Okay? You begin the process, you make progress, you become confident that you can actually do this. You can design and develop the seatbelts in time to get into production, but you conclude that you're not going to have enough time to actually test them, to show that to prove that they're effective. What do you do? This is the kind of question you might get asked on a job interview. Okay? So this is a clicker. These are your options, and I'll give you a little extra time this time. One, you can cut short the design process and proceed with testing that you've done so far. You can say, all right, we're going to do the best design we can and forego the testing because we have really good calculations. You can just say, sorry, it's not looking like we're going to get there. We're going to give up the contract. We'll give back the money. We might even have to pay you a penalty for wasting your time. Right? Or you can try to negotiate with the customer to change the contract after it's been signed. And I say try. Give yourself more time. Or you can fire the people who got you into this conundrum by overcommitting your company. And odds are they asked you, the engineer, whether you could get this done by the 180 days. And at the beginning you said, yep. And that firing that person might include you. Oops, get this out of the way. I could have sworn I gave more time. I guess not. All right. Whoops, where'd that go? All right, hopefully I didn't lose that. But most of the answers were, I think, negotiate with the customer to change the contract to give you more time. This sounds like the classical student response. I didn't get my homework done on time. Can I get it to you next Monday? Because teachers are suckers, right? More times than not, they'll say, yeah, sure. This is the business world. They will say no, frankly. Or when they wrote that contract with you in the first place, there was some fine print that says every day late, you give them back $10,000 or whatever. Depends how big the contract was in the first place. Their lawyers are good. And anything negative, anything that you violate on that contract, they might be 100 days into the 180 days and they've bet their business on your production. They can't walk away from you now, but man, they're going to make you pay for messing them up. Okay? This is the reality of the world. So number 4, you can try. And they'll say, sure, you can get them to us in 200 days rather than 180 days. And read subsection 4, part 4, paragraph C, and send us the check. Okay? That's going to be the way it is. And then the repercussions at your company will be, you just cost us $30,000 for being 30 days late. You told us you could get it done on time. And then they rapidly advance to number 5. Okay? What about numbers 1 and 2? Cut the design process short and just say, all right, we cannot proceed to market without testing this. It's a seatbelt, for crying out loud, right? You can't just say, yeah, it'll work, and say, no, we never actually tested it, right? Because the first person that gets in a car accident, their lawyer is going to say, how many times did you test that seatbelt? With you, the engineer, sitting on the witness stand as the expert who made the product that hurt their customer, their client, okay? Finish the design as much as you can and don't do any testing, Well, I guess that's sort of what I was just talking about. Cutting the design process short in doing the testing, what this might mean is you are going to the plate with a product that you know is not your best effort. This is what students tend to do, right, with their assignment. Right? The final exam is this day, and if they're not making that deadline, they hand in what they've got. You guys hand in what you've got. This is oftentimes the one that makes sense. It might not make sense for your company because if your company has to go to market with a substandard product, you might be losing that race before you ever get to the start line because Apple or Microsoft is over there who didn't screw up, and their product is top-notch on day one. Okay? So maybe giving up the contract and paying the penalties is best because that customer, you're not really disappointing them. They're getting a fair exchange for the harm that you caused them, negotiated by contract on day one. They say, all right, you can't do it. Give up the contract, give us back the money, and pay us the penalty for wasting our time. These are how business people work out these types of things. So any one of these really is a viable approach to the problem. There's no right answer here. But this is a real-world question that you're going to be asked at some point, most likely, in your career, and maybe even before your career begins. This is a classical question that you'll be asked at an interview. And they won't just ask you one. They'll ask you to explain why you didn't pick other solutions. Okay? Oops. Okay. So there are always trade-offs. And the idea of efficiencies and economies are always going to be complicated. And you, as a practicing engineer, have to put together your good old common sense with all of the sprinklings of knowledge that you get from science, engineering, design, management, all of these other skills that you've learned along the way. None of those are going to stand on their own. So, kind of coming back to where we started, you've got to make decisions. Okay? There are a lot of different aspects that go into planning a project, into designing something. Safety, quality, how fast it gets to market, what the costs are going to be. You can probably call safety part of your quality, but it's important enough to pull out and have it stand on its own. Frankly, safety is always the trump card in the game of design and in business. If many products, safety is not an issue. The programmers who wrote Angry Birds or whatever, safety is, and that's the safety for the birds, I guess, but safety is not an issue for some products. But other products, it is everything. And for many products, they're somewhere in between, where in their most use, it's not a big deal. You make Legos. Do you think Lego is concerned with safety? Well, the first little kid that swallowed a block and choked, well, you get the idea. So you might not see safety as being the main objective, but you've got to think outside the box. How stupid can your customers be? Okay? That's quite frankly the truth. I mean, I do consulting work as a metallurgist, and we look at failure analyses a lot, right? And I had a case where somebody ended up, you ever see those sidewalk trimmers that they spin a blade and they walk along the side of the sidewalk and it cuts all the grass? Well, somebody actually ran this into a tree and ended up with a blade in their face, okay? You might say, well, why'd you walk into the tree, right? Or well, why'd you run it into the tree? And that's a reasonable thing to say. You will lose in court every single time, okay? You have a responsibility as an engineer to make your products safe. And what safe means is up to a jury someplace. And there are decades, centuries of case law that says that you have to go pretty far out of your way to ensure that somebody is not going to try to, this is another one I've heard of. Somebody picked up a lawnmower while it was running and used it to trim a hedge. Well, let me rephrase that. That was their aim. That was what they intended to do. They never got it off the ground, and I think you can envision why. Okay? People do some stupid things, and sometimes putting the warning sticker on the side, I mean, these days products are getting ridiculous, right, with all these disclaimers, do not place knife in mouth, those types of things. Because somebody someplace did that before, and a lawyer someplace said that, all right, we got to cover our butts, and that's why the user manuals for a water faucet are 16 pages long. Okay? So all of these things have to be factored in. So judgment calls are going to be important. In many situations, these judgment calls are going to cost your company money. And sometimes it's unavoidable. And just because you say to your boss, no, We can't do it that way, or it's going to cost X, Y, Z. That doesn't mean they're going to fire you, right? They might not like to hear that, but you as an engineer have to stand by your guns and say that this is the way it is. I can't get blood from a stone or whatever. This is what the cost is going to be, and it might put us at a disadvantage to a customer or to a competitor, excuse me, who maybe was farther along the game than you were. That is a business decision that is rooted in the realities of the engineering and the design process that are going to affect everything. So, finally, I really have to reiterate this thing. Safety trumps everything in the design process. Cost, time to market, quality, but I'd say that safety really is a built-in part of quality. You really need to make sure that you get these things taken care of. In this day and age, there is no amount of testing that is considered enough by everybody. You will be, maybe not you personally, but an engineer who designed a bicycle will be sitting on the witness stand because a little kid's bicycle forks broke and they went over the handlebars and they lost 2 front teeth or something to that effect. And their lawyer will be asking you, how many times did you test this fork? And you'll say, I tested that thing 100 times. We have 100 broken forks sitting in our lab where we broke every single one of them to see how much of a load it would take. And they're going to say, well, why didn't you test it 200 times? Okay? That's the nature of our world. And it'll be left up to a jury to decide. Hopefully you'll be able to convince them why 100 times was enough. But there will be people who are not engineers judging your engineering decisions on these types of things. So the knee-jerk reaction on these things is to make it as safe as possible. But then your boss will be saying, put your knee back underneath you because every test costs us money. And you say, all right, okay, maybe not. You have to figure out how much is enough. And these are not easy decisions to make. As an engineer, you will, along the way, hopefully develop skills and understand sometimes there are standards that you have to test to. Sometimes there are rules and laws that you have to accommodate. You have to be familiar with those. Question, Outback? Good question. Why does it bear onto the engineer and not the government agency to make these judgment calls? Frankly, because the way our world works, we don't want Big Brother looking over our shoulders. Engineering is a profession where you have to be licensed for what you do. People are going to trust that what you said was good enough is indeed good enough. That's what licensing is all about. You'll hear a lot more about licensing between now and by the time you graduate. Many of you will need to be licensed before you can be considered a professional engineer, especially in civil engineering. When you say that bridge is not going to fall when 15 cars are on it, it means that you have something backing up that statement. Okay? There are laws and guidelines and government rules and standards that we have to subscribe to and comply with, but they're so complicated that there's nobody in the government who's going to be looking over the shoulder of the engineer making Legos. Okay? That's not the way it works. They trust that the engineer knows the rules and that that company is responsible. There's many levels of responsibility. This is a topic that's way more complicated than we're going to cover in this course. Companies accept some responsibility, but ultimately it's going to go down to the engineering. So, I covered all that. Do not overlook these things. If you have good common sense skills, you're on the right track. Figure out how to marry those to your engineering skills. We'll see you on Monday. And we have a guest speaker on Monday. Behave.